So welcome to this latest edition of ABN Cast. My name is Lee Hayhurst. I am the editorial director of Aviation Business News, and I am here in the ABN Cast studio. Today we're going to have a chat about supply chain issues, which of course have been in the news recently and have been for some time since COVID in aviation. And we're going to talk to Emmanuel Marquis, who's the Executive Vice President of TRIGO Aerospace. And they've recently put out a report on supply chain disruption, particularly in the US, but I think it probably does apply globally. So welcome, Emmanuel. It's good to see you. You're joining us from France.
Exactly, Lee. I'm glad to be there and participate to the podcast there today. So I'm currently in Toulouse, the big hub for aerospace activities in France, where my office is located at the moment.
Great. Okay. Look, give us some background to this report. Like I said, it's clearly a big issue that's been taxing the aviation industry for some time. So it's not surprising that you want to address it. But what was behind the thinking of the report when you decided to do it?
Yeah, the thinking of the report and then basically the genesis of that report came from many discussions and interviews and debates we had with some of our customers struggling with the supply chain. And as you mentioned it in the very beginning of this conversation, since COVID, some of the problems in the aerospace supply chain that were there have been greatly amplified by supply chain disruption, lack of material, lack of manpower. And then this report was, in a sense, trying to translate from a feeling that we had in working with the supplier and their end customer into some data here to substantiate some of the ideas we had at that moment on regarding the root causes of the supply chain disruption we are seeing in aerospace. And basically it was trying to unveil the hidden part of the iceberg. Okay. If you listen to the press and so on, you know that every day people are saying, yeah, we have supply chain issues, we don't have the parts, the material are under shortage. But this is I would say a mainstream opinion, but does it substantiate in numbers? What if we clearly look at all the root causes one by one, we analyze them, and basically, is it an impression, is it a feeling, or is it a real number-substantiated root cause when we say, well, we have an issue in, I don't know, let's give the example of manufacturing landing gears and we can't find the parts. Okay, we cannot deliver the end customer and so on. But is it really the root cause that we think it is? And that's why this report is a little bit trying to find the dead angles or the place you don't look, but where you can find data and work on it.
Okay.
That's in a nutshell the genesis of that.
Fine. Now, look, before we get into the what you found in the report, you actually start it by quoting the CEO of GE, Larry Culp, and this gives a bit of background, I guess, to the issue. Where he says that everything that that's going on would suggest that this is going to be a daily battle for the foreseeable future. So this is something that the aviation industry is going to have to just deal with. It's not going to go away overnight, and it's going to continue. And we don't know for how long it's going to continue for. What's your sort of feeling on this? Is this something we have to just accept as being a sort of slightly new normal?
Yeah. My feeling is that some of the new normal, as you mentioned it, like the lack of qualified resources, the lack of manpower, or the scarcity of some rare metals and so on, my feeling is it's not going to change tomorrow morning. So either we have ways to adapt the aerospace industry to this new normal phenomena, or the supplier and the provider who don't adapt to this new environment, I mean, they will suffer great damage and maybe they will get away from the market. So for me, this COVID was just a trigger showing a long-term trend. And if I take a stupid example, I look at the labor market in California. It's overly difficult to recruit aerospace engineers in California.
Yeah.
But if you are an aerospace parts manufacturer, what can you do with that? If you are a small company, 200 people in California, you can't hire anybody. So you need to find alternate ways to turn around that problem. And basically, you cannot bet that this situation is going to change, because well, look at the labor market in California. It's been tense in the past 20 years, and it's still going to be like that for the next 10 years, I guess.
Yeah.
So there's a great need for change management on some of the principles of aerospace industry that have been there for the past maybe 50 years are not there anymore. So that's a big Darwinian change that the companies are facing now.
Yeah. In the report, you also preface the findings by setting out how there is a lot of attempts. There's attempts by the OEMs to increase production. You mentioned Boeing in particular, because demand is so high, and obviously the demand for flying is pushing that, and that's since COVID has come back very strongly. So they're talking about bringing out more of the production lines becoming more productive. But obviously we've seen, and it's been in the press, and it's not been hidden because we've had the issues in the States with the whistleblowers. This is having a knock-on effect on quality. And you say in your report, it's very likely that late deliveries will lead to lower quality levels at the final assembly stage. So just a few thoughts on quality, what we're seeing at the minute. I've heard Willie Walsh from IATA explain, look, the industry is still extraordinarily safe. It's had the safest year in 23, and 22 was the safest year prior to that. So it's a very safe industry, but clearly things have hit the mainstream media, and that is a worrying sign because you don't want to start to undermine people's confidence in aviation, do you?
Yeah, and in fact, the aviation industry is one of the safest one. If you look at the number of quality checks, procedures, regulations, and so that is applied, and you look at sadly it exists, but the accident rate due to parts failure is extremely low in the industry, and the rate of failure of this transportation is extremely low. And this has been achieved by continuous improvement all over the place since the 1950s and so on. But in parallel, and what we've seen is, if I look at the way aircraft were manufactured 50 years ago, and if I look at the way it is now manufactured, there's a big change in the supply chain. Basically, globalization has made it. And so there's an element of complexity that is added to this quality check and quality control, is that when it was done if you look at the Boeing factory in 1940, everything is in 1 mile radius.
Yeah.
So it's a small community. Now, everything comes from all over the place on the planet. And so the quality philosophy, the quality checks that have been deployed in the 50s, 60s, 70s to reach that quality level in aircraft, now you have the challenge to deploy it globally. So whatever the part wherever it comes from and wherever it goes, you need to have the same quality check anywhere on the planet. In a situation where we have less and less people available, manpower is a critical issue. And so that's one of the, coming back to the report, that's one of the intent is, do we have, low-hanging fruits to improve on-time delivery and on-quality delivery in the aerospace supply chain that basically we can trigger now, execute now, and so alleviate a little bit the need in additional resource and reduce the complexity to maintain the quality level.
Yeah. The report looks at, you mentioned that just now, OTD and OQD, so on-time delivery versus on-quality delivery. It's fairly obvious what those things refer to, but explain a little bit about how those two things play together.
So these two concepts, OTD, on-time delivery, means basically it's a performance indicator of the supply chain that says, do I receive on time for manufacturing the aircraft all the parts that are needed? So an on-time delivery, which is a percentage, is basically the percentage of parts that arrives on time. Mm-hmm. And to make an aircraft, you need 100%. So if you have an OTD of 99, that means you still miss 1% of what you need to do the final assembly of the aircraft. It could be an engine, could be a nut, it could be a seat, but whatever you cannot deliver to the airline. So basically everybody needs 100%. Provided you may have some buffer stock on some critical items and so on. And so that the standard rate is more in the 95, 97, 98%. And then with the stock, you manage to make your aircraft on time. And the second performance indicator is the OQD, on quality delivery, means the part that you deliver, obviously on time this time, you get it with the proper quality level. And proper quality level in aerospace means, okay, the part matches the spec, it has the full documentation, it has been shipped and delivered undamaged, and it's ready to be installed on the aircraft. Yeah. And basically, you understand that these two performance indicators are linked, because sometimes if you don't have the part at the good quality level, can you consider you received it on time? Because it's not at the good quality, so you are going to ship it back to the supplier and you receive it later on. So basically, it has an impact. If it's not at the proper quality level, it's going to be late. And sometimes on the other side, if you are not on time, sometimes you need to expedite a few things. Yeah. And expediting a few things sometimes means you are going to do a few shortcuts in the manufacturing process or in the packaging or in the transportation, or you're going to rush something. And then you have a risk that it translates into a quality issue. So basically, to manufacture an aircraft, you need both these two KPIs at 100%. Which you not always have, in fact, obviously. But that's what the industry needs, and that's the trend that you need to have. And that's where you need to put your efforts on the supply chain, basically, because these two numbers give you a very good indicator of what your supply chain performance is.
Yeah. Oh, right. Look, let's delve into the findings. You said earlier we're looking at the part of the iceberg we don't see. So this is the We've seen the tip. We're now looking at what's below it. So let's just explain what were the key findings, and what do you think is the most interesting thing that you did find?
Okay, so basically, we started from the listening to the GE CEO and all the supplier, the customer and in the industry saying, well, we have issues with the supply chain. The suppliers are not good. They are not delivering on time, and so on. So we did a little bit of data crunching. So that's going to be 2 sentences for millions of lines of calculations. But what we did is we took 500 aerospace suppliers in the US, and we calculated the on-time delivery line by line over 18 months of all these suppliers. So that's 8 million purchase orders that we've crunched to do that. And we classified the root cause of basically late deliveries. And then we categorized them into 2 categories. One would be, is it the responsibility of the supplier? Basically, is late, doesn't have the material, and all of the classical reasons we have. And then we had another category, which is responsibility of the end customer who's buying the parts in creating disruption in the supply chain. And basically, the common sense would saying, okay, but everything is 95% responsibility of the supplier. As usual, they are late, they don't have the resources, they don't manage well the quality, and so on. Yeah. And in fact, this analysis showed that basically there is a kind of industry standard which say that 2/3 of the late deliveries are the responsibilities of the supplier and 1/3 of the end customer. Okay. And that's the iceberg, because nobody ever talks about that, because basically it's not the common practice of the end customer to say it's my fault if my parts are late. It's not going to recognize it. It's not very well analyzed. In fact, you in a supplier to customer relationship, you would focus on if the supplier is late and the contract and so on. You do not perform a big analysis on the end customer responsibility. And second step, we did an analysis of the root causes one by one. What's creating this disruption? Why is the end customer doing that to his supply chain, in fact? Yeah. And basically, none of the usual suspects, material, manpower, and on, show up in that list. And that really, honestly speaking, even for me, which I had the feeling that was coming, it was a shock. Okay. Nobody ever talks about lack of manpower, of material in this. Say 1/3 of the late deliveries in the aerospace industry do not connect directly to the mainstream explanation that we see on a daily basis in the press.
Right. So things like lack of manpower doesn't seem to factor. But you've listed, I think, eight factors that are the root cause of this customer-centric reasons for late delivery. Go through that. There's 8 of them. There's quite a few to go through. But what were the main ones, do you think?
There's a lot of scheduling issues and engineering changes. If I start from the beginning, I started with the change of schedule because a lot of the end customer basically changed the production schedule too fast for the supplier.
Okay.
That means the time you propagate your schedule change into a supply chain that is 4 or 5 levels and which is spread all over the planet. I mean, if you change the schedule faster than the information propagates in a supply chain and the supplier has time to adapt, you have the recipe for a problem. And it's often underestimated because you change the schedule, you call your tier 1 supplier saying, hey, this delivery is moved from 1 week to another. But in fact, the complexity of the supply chain with tier 2, tier 3, tier 4, tier 5 into several countries all over the planet is not taken into account when an end customer does that. And is basically creating he does not even know he creates a problem. He will see it at the end because, in fact, the new schedule will not be met. So there will be a new change of schedule, which will not propagate in due time. And then this vicious circle keeps on running the whole time of the program. And it's not visible.
Yeah.
The second point we have here is the engineering changes. And I've seen a lot of the design engineers doing changes to the drawing, and the same issue happens. This information does not flow properly into the supply chain, basically.
This is a communication issue. Is it there?
It's not a technical issue. It's not a capability issue. It's not a machining issue. It's just communication. And a lot of the issues are communication issues.
Yeah.
I mean, you have to make sure your supplier understands what you want, and he needs to be in full awareness of all the processes, the complexity, and so on. And when you have 2,000 suppliers for a small aircraft, I mean, it's a very, very complex human issue here.
Yeah, and that goes back to what you said at the beginning about the complexity of the supply chain these days, which has become more complicated and more global. So that's the first two. Are these in order of importance, do you think, or are they all equally as important?
In fact, it was tough to put a very specific order. There are two things that are worth noting. Yeah. They are never alone. There's never one single root cause in a supplier to customer relationship. So there's always a mix, and it can be different from one end customer to another, because for some of them which are not very good on scheduling, you have a lot of scheduling issue. For some other engineering, for some of them the missing purchase order would be highlighting. So there's no general rule to say, well, it's always a change of schedule first. It's really also dependent of the culture and the history of the end customer. Yeah. If you have a weak manufacturing process, then you have manufacturing process issues coming. If you have weak scheduling, you have this. But I cannot give a rule saying, okay, this is problem number 1, 2, 3, 4. I think they belong to a package.
Looking at the list, there are other sort of more just business bureaucracy issues like missing purchase orders and late payments. These are things that all businesses have to cope with. But clearly in this situation, it causes huge amounts of disruption because of this complexity that you've been talking about, hasn't it? Yes,
sure. I mean, people would say the purchase order as a paperwork issue or an administrative issue and so on. When you go down to a very small supplier, which is a 5-people company, and they need the cash absolutely on time to buy the material, and then they don't have the firepower to go to the bank and say, well, I am this big company, I can borrow money. And so the same way here, as you can underestimate the communication issue, and sometimes the financing issue for very small supplier is critical also.
Yeah. So you say what you found is you found a very interesting correlation. I'm quoting the report now between supplier performance and customer discipline. So let's go to some of the solutions that potentially could arise out of what you've found. What do you think is technology is always a good solution for anything if you apply it correctly? Is there a technology solution to this? Or is it about organization, manpower, etc.?
Yeah. So let's come back a little bit to the this question of pushing further the analysis, and I try to to go deeper in the root causes creating supplier late deliveries and see how. I mean, my philosophy is if you want to solve a problem, you need to understand it very well. So there was the question of getting the iceberg, okay, and getting the data. And then we deep dived a little bit more into it to fully understand what was happening. And that's why we tried to categorize, in fact, the end customer into two categories. Category number one is the one that basically don't interfere too much and don't create too much disruption at their supplier. And what we found is that this end customer usually have very good performance from their supply chain, in the 85 to 99%. And then there's another category where the percentage of customer-induced supply chain disruption is over the 30% of industry standard. And what we discovered is, in these cases, the supply chain performance never exceed 85% on-time delivery. So that means that basically, if you are an end customer and you have a high responsibility in the disruption of your supplier, you'll never achieve more than 85%. Right. That means also that if you want to achieve more than 85%, you need to change category.
Yeah.
And then comes the question of the change management, is how can I change category and how can I go there, knowing that we are in a situation where you have a lot of difficulties to find manpower to do that. So you are facing a change management issue, and you can't find the people to execute that change management properly. And then you need to find new technology to focus your resources where you want them to be focused. And so that's what we worked a little bit at TRIGO on the predictive analysis. If I know in advance which kind of supplier is going to fail in the next month or 2 months or 3 months, then I can dedicate my firefighting resources intelligently to the place where it's going to be needed, and not focus the energy and the firepower between brackets of the organization on topics where nothing will happen.
Yeah.
And so in a sense, there's a way through the use of computer science and artificial intelligence to be able to predict a little bit what's going to happen in your supply chain in the coming months, with the capability to dispatch resources on the hotspots, and then getting out of the permanent firepower situation where you don't know exactly what's going to happen. I mean, you are solving yesterday's problem and you don't know what's going to happen tomorrow.
Yeah.
So what we are trying to do with that kind of analysis and the use of predictive model is to say, okay, if you want to break this vicious circle of trying to correct yesterday's problem with less and less manpower, the use of big data and artificial intelligence will help you to predict where it's going to happen. And then you can exit this circle and go into continuous improvement again.
Yeah. Yeah, we under MRO management, we run the Predictive Aircraft Maintenance Conference every year. We've just announced it's going to happen in Dublin this year in November. And obviously a lot of talk there is about the predictive element to predicting when the parts are going to fail and being on top of that. But actually, so what you're saying is you can sort of go backwards on that and say, let's predict the supply problems you may have when you know things are going to be needed in the future, which is an interesting sort of way of looking at predictive. It's going backwards almost into the supply chain.
It's back one stage.
Yeah.
When we climb the mountain reversely. So and the goal is trying to be able to have a prediction. That's a kind of a weather report, so it's not always true. I mean, let's be honest, but it's the model we are having works at 95% at the moment. Yeah. 1 month to the other month to say these are the supplier and the parts which you are going to have issues on the deliveries. And this is basically one step ahead to what you mentioned on maintenance. You can predict when a part is going to fail. Here we are tackling the problem of trying to predict when the supplier of the part is not going to be able to deliver it.
Okay.
So one stage earlier, and a slightly different topic in a way, because here we assume the fact that the part is brand new. So what you're going to get is a brand new part, but you may not get it on time or on quality, and that's what we want to tackle.
Yeah. All this data you crunched, you mentioned how much data you crunched. You've created a graph in the report. And you identify something called the on-time delivery sound barrier. Just explain what that is.
Yeah. Well, I like the concept of the sound barrier. It's something you cannot breaking unless a new technology comes in. And what I've seen from the analysis is that the sound barrier rule is that you cannot exceed 85% on time and delivery in your supply chain if your share of customer induced late deliveries is over the 30% mark. Right. So if you want to break that brick wall, the sound barrier was seen as a wall in the sky before the Bell X1 broke it in 1946, but that's the concept. If you want to break that, you need to move and you need to change the way you work with your supply chain. So you basically need to change the way of working with the supplier and the way you handle the change management, the scheduling, the purchase order, and so on, if you want to go over that limit of 85% on time delivery.
Okay. So this is what you've discovered some interesting stuff in this report, which probably people hadn't thought about previously. So if people want to find this report, it's available on your website to download. Is it?
Yes, it is.
Yeah.
Yes, it is.
Okay. Let's just think more broadly before we finish about this sort of area generally. You talked about new parts, but there is the secondary market of parts out there, and there is aircraft coming towards end of life, and those parts are being recycled back into the system. Is that part of the solution here as well? That there's a better system to get those parts back into the system so that they're available when they're needed?
Okay. Basically, this analysis was done on new parts because that was the data that was available at the same way. But this is fully applicable to, second-hand parts or refurbished or re-engineered, because they will re-enter a kind of process with the supplier re-engineering and basically checking the parts. So what I think today is that the same mechanism will be applicable to new parts, original parts, and also refurbished ones.
Okay, yeah. You make a point towards the end. We talked about the manpower issues in aviation. They're well known, particularly in engineering. Particularly, there's not enough engineers, and that's not going to be solved anytime soon. But on the flip side to that, you mentioned the fear that innovation and technology is going to replace workers. What's your personal view on that? Should people be worried about their jobs, or are they just going to change because innovation and technology changes the nature of work?
What I believe here is that and all these new technologies like artificial intelligence, neural network, assisted optics inspection, and so on, it's not going to affect the existence of the jobs. I think in the aerospace industry, there will always be quality engineers and quality inspectors. Okay. What this new technology is going to create, it's going to assist the engineers and the technicians and the inspectors to do their job better, basically, to make them more productive. And that's my strong belief, is that artificial intelligence will be an amplifier. Yeah. That means quality engineers would have the capability today to solve, maybe 2 major quality issues per day. And with artificial intelligence, he may be able to go to 3 to 4 to 5. So in a nutshell, I do believe this computer-aided or assisted quality engineering will simply be a mitigation to the manpower issue. What you are able to do with 10 people tomorrow, you only have 6 to do it today. So the way to do it is basically to have assistance, support, and artificial intelligence is one of the means here to help the people working in the quality in the aerospace. But I'm completely convinced it's not a threat to their job at all. Yeah, it's basically I would see it as a big help. Yeah, because if I come back to my predictive discussion, if you don't know, say you are a quality engineer and you have a portfolio of 20 suppliers you have to monitor permanently to make sure they deliver on time and on quality. If you have no system, you don't know what's going to happen tomorrow. If you have a little bit of artificial intelligence that tells you, well, by the way, take a plane to Dallas because the problem is there tomorrow, it's basically going to make you work much more efficient. And you will be much more relaxed on the admin task and the automation and so on to focus on the real core of the quality engineer job. It is, look at the root cause and propose solutions to mitigate the problems. So I see it as a great progress and not at all as a job killer, as some people would say.
No, there's a really great point was made the other week. I was at Aerospace Tech Week in Munich talking about AI and adoption of AI, and it was said there, and I totally agree with this, is that not enough time is spent asking the people who touch the aircraft, people who've got a vested interest, the stakeholders, in what they would want out of an AI or technology to make their jobs and lives easier. There's a lot of focus on the pilots possibly and the crew and obviously the passenger. But what about the cargo loaders and the cabin, the luggage loaders and the MRO and the engineers? What do they want out of this? If you were to ask them, they will tell you, and then they will accept it because they do see it as being something that augments what they do. And I think you say in the thing, the sweet spot is to combine human expertise and deep tech tools to boost production outcomes. And of course, everyone wants to achieve that. So yeah. So look, our time has beaten us. We've done about sort of half hour, but that was a really fascinating insight into the supply chain issues that we all been talking about. And hopefully, an insight people haven't seen before because we're delving beneath the waves and looking at the bit of the iceberg people don't tend to see. So, Emmanuel, thanks for joining us. Really appreciate that.
All right, thank you very much, Lee.
No, great. Thank you very much, and we'll see you soon. Bye-bye.
Bye.
We're delighted that our friends at Amadeus have agreed to be the launch sponsor for ABNcast. And while they do not